these next ones we're going to look at how do you find an estimate for the infinite sum. Well, we're going to take what we know here, that our air is our sum of our infinite part minus the sum of the first n terms. We're going to substitute that in place of r here. So now our inequality becomes that we got the sum of our infinite one minus the sum of the first n term should be less than or equal to these two units. And then, if we were to add the sum of the first n terms to both sides, so we're adding it to get rid of it out of the middle, that means we need to add it here and also add it over here. We get this statement. And this is what we're going to use then to estimate the sum, the infinite sum here in the middle. It should be the sum of the first n terms plus that integral, and then the integral plus 1. So that on either side you need to get a little extra and kind of narrow it down. So I think we can do that for the example we were just looking at. We want to estimate with n equals 10 to estimate the sum of the series. So we found the sum of the first 10 already. The sum of the first 10, we used a calculator and we estimated that out here. The value that calculator. Yeah, we estimated that that came out to be 1.19. 7531936. Okay, so now what we're going to do, to find our infinite sum here, our infinite sum should then be less than s of 10 plus this integral from 10 to infinity of 1 over n cubed. With this issue x cubed dx, and then on the other side it'd be the 1 more. So it's going to be our same s of 10 here, plus the integral now from 11 to infinity of dx. Now previously we had gone through and found that antiderivative of this comes out to be this is going to come out to be for this problem. We got our estimate value here of s of 10 plus this came out to be 1 over 2n squared. And so same on this side, this is going to come out to be our s of 10 value plus 1 over 2n squared. The difference is what our n value is. Here it's going to be 11, here it's going to be 10. So what we're going to end up with is that this is going to be 2 times 11 squared. And over here, this is going to end up being 2 times 10 squared. And again, where we got that from was from our work on a previous problem. Here where we went through and we did the integral of, and we found out that this is always going to be, that our R is here is going to be 1 over 2. All right, so let's keep simplifying it. Now we know our values here, so we can put these in. Our S value is our 1.19, and so on. And if we do this one on our calculator, it's going to come out, we've done that one already, it comes out to be 0.005. On the other side here, we're going to have that same S value of 1.19. Plus, we haven't done this one yet, so I'm going to calculate it. E over 2 times and that's going to give us that out, 0.0043. And so on. So now we want to add these up and see what our what is our infinite sum going to be this year. And if you do that on this side, we add these up. And on the other side, adding this. So we know now our infinite sum is going to be somewhere between these two values. So we started to narrow down our